Thank you, Doug. Ooh.
If people want to, can people move in to the center so that other people can get seats? There's a lot of seats available. I see people standing, unless we want to be standing, but everyone could shift in a little bit. Yeah, I know it's hot in here, but you know, this topic is a hot topic. All right, thank you so much, everyone. Appreciate it. Plenty of seats, packed house. All right, I know a few people are coming in here, but hopefully we'll get everyone in, and by the time I get you up here, Charlie, everyone will be settled. Good morning, everyone. Thank you so much for being here. How are we doing? This is, last full day of programming, yeah? Having fun, exhausted. There was a funny tweet last night. Coalesce has been amazing, love this week, but I am looking forward for Coalesce to be over so that I can convalesce. Which I enjoyed. Okay, my name is Jillian. I lead the community advocacy team at DBT Labs, and I will be your host for today's session, Demystifying Event Streams, Transforming Events into Tables with DBT. I am so excited to introduce you to our speaker, Charlie Summers. Charlie is a data engineering tech lead at Merit, and I had the pleasure of meeting him back in May as we opened our CFP for Coalesce. Since joining DBT Labs last year, since I joined, my absolute favorite part of the year by far is Coalesce CFP season. It is like Christmas to me. I open up my calendar to new and first-time speakers who most of the time just need me to affirm that, hell yes, this would be such a rad topic. The community wants to hear this. Charlie lit me up when we met. I have a sweet spot for engineers who just get analytics engineering and intuitively understand the benefits of bridging the gap, blurring the boundaries between software engineering and analytics engineering. I think we need more people like Charlie, which is why I'm so excited for him to come share some concrete guidance on how DBT can be implemented in more traditionally software engineering infrastructures. If you haven't noticed, Charlie has some of the sickest ink I have seen all week. Yeah. Be sure to check out his homage to Shakespeare tattooed in binary on his bicep. Really quick, before I bring him up here, just a few reminders about participating for anyone tuning in online or those in the room. The conversation will be taking place in the DBT Slack. The channel is Coalesce Demystifying Event Streams. Please jump in, ask questions of other attendees, make comments. Emoji reactions are always welcome, especially purple flames. Charlie will jump into the Slack after the session to answer questions. With that, please give me a warm, loud, rambunctious welcome for Charlie.
Thanks, Jillian. Hello, everybody. First off, a couple of thank yous. Thank you so much, Jillian, for that introduction. And thank you to DBT for holding this awesome event. This quick round of applause maybe for like Coalesce in general. Yeah. Yeah, this has been so much fun. I've really enjoyed getting to know a lot of you and just being here. It's been awesome. Also, a quick thank you here to Manbir here in the front row. He was my partner in crime in building a lot of this stuff, and he'll be answering a lot of the questions on Slack if anyone wants to throw anything in there until I join after the talk. And then finally, thank you to all of you for coming. I really appreciate it. This is a fun topic. It'll get a little bit into the weeds, and hopefully folks enjoy it there. So today I'll be talking about demystifying event streams, transforming events into tables with DBT. So a little bit about me. My name is Charlie Summers. I'm the data engineer tech lead at Merit. It's a Series B startup, about 100 people. It's a digital credentialing platform. And really, what inspired a lot of this content is over the last year and a half, we've been doing a large-scale platform rebuild where our core platform has been getting a total facelift. So what does that change look like? Before, this application architecture might look familiar to some of you. We had an application on the left that used a relational database. We used Postgres. We ETL that data into our warehouse, and then finally we build dashboards on top of that data. And of course, in that warehouse, we're doing transformations with dbt. So what does it look like after this platform rebuild? Well, we did a couple of really useful things that are enabling us to scale. So first off, we broke apart our monolithic application into a microservices architecture, where instead of having a single service with a single database, we now have a bunch of smaller services with a bunch of smaller databases that each hold the application state for that particular microservice. And in order to coordinate conversation between these microservices, for example, the user service might say, hey, a new user was created, and a notification service might want to send an email saying, hey, thank you for joining our service. We use an event platform in what's called an event-driven architecture. So what that means is, yeah, all these microservices are sending events between one another in order to share state. And really, we're not even trying to very often do API requests between one another, which has some really nice benefits that I'll go into in a little bit. So in this architecture, our engineering team, our engineering partners decided on the left-hand side of this diagram. But the right-hand side, we had a couple of questions. So the first off, we could do something very similar to this past architecture where we ETL everything out of, in this case, every single database. But we actually chose, or actually, we were told by our engineering teams not to do this. The reason we didn't want to do this is the same reason why microservices between each other don't look directly into each other's databases. And the reason that they really prefer not doing that is the database for an application ends up being, there could be a bunch of hacks and challenges and things put into that database that are specific to that particular application, that are supposed to be performance optimizations. They aren't necessarily designed for outward consumption. So, and the challenge is when those databases inevitably change, what are the downstream things that break? This isn't unique to a microservices architecture, but it is, a challenge that we had been running into, where if something in the database schema changed, if we just, ETL'd that into our warehouse and started building dashboards on top of, that transformed data, the dashboards could break. And we ran into this a couple of different times. And so going forward with this new platform, we decided, hey, we're just not going to do it. So we ended up in a scenario of, what should we do? And we noticed that already these microservices were passing these events between each other. So we wondered if we could just directly pull these events from our event platform into our warehouse and build the same type of tables off of them. So really, the challenge is now, instead of these nice tables that some great tools like Fivetran, for example, or Stitch, or Airbyte, or Lautano, or all these great tools will provide to you, we just have these raw event streams. They look a little different. I'll show you what they look like. And the question is, we still need to ask the same sorts of questions over our data, so how do we make them look like tables? Yeah, so that's what I'll be talking about today. This is very much like an in-the-weeds project. I'm not even saying that this is the best way to solve this problem. And in fact, if any of you have ideas or questions or have solved this at your companies, I'd love to talk about it. If someone corrects me and says what we did was better, I'd love to just use it instead of, I'm not promising this is the best idea or the most novel idea in the world. But hopefully we can share it and get the conversation going. So a quick overview for the rest of the talk. We'll talk a little bit about what are events. We'll describe why events might be good contracts. I swear, I ended up talking about data contracts. I didn't know what that term was when I submitted my proposal, but here we are. The next talk actually talks exactly about data contracts, and please go to that one. They're going to probably do a lot better job than me. Then we'll describe what the contract actually is, what we call the OMG contract. And then finally, we'll talk about how to build a reusable pipeline leveraging dbt macros to process all of this data coming out of the OMG contract. And then we'll talk a little bit about future ideas and other cool stuff we're thinking about. So what are events? Events are published by a service to a topic. There could be multiple topics, each describing a different type of event, user created, product created, organization deleted, whatever it is. They leverage an event platform. So Apache Kafka is the one that we use, but all of the major cloud providers have their own. They're subscribed to by other interested services. So as I mentioned, like the notification service might be interested in lots of events. And a couple other characteristics of events, especially how we use them. We use what are called thick messages, meaning that an event could just have, for example, the ID of the user that was created. Instead of that, we actually package up all of the information that the user service has about that particular user that's created and ship that along with the message. That means that downstream services don't need to make additional REST API calls in order to have that information, but instead it can be cached in, like, in their local database. And yeah, it means that there's less overhead of communication when you actually need to action that data. And then finally, events are not commands. So the best way to frame this is events are past tense. I just did something. A user was created, not please create a user for me. When you start sending events as commands, that's another pattern that people do, but we don't at our company. It can make things a little bit tricky because you might say, hey, please create a user for me, and then wait for another event where you're saying, the user was just created, and then the first service is spinning, waiting for that to happen. And you might as well have just made a REST API request. And it makes things a little bit more asynchronous, but yeah, that's not what we're talking about here. So particularly they're events about what happened. And then finally, they have well-defined schemas. So we use Apache Avro. I think in the next talk they're talking about JSON schema for contracts. But basically what that means is all of the events have the same data in it. Cool. So let's walk through how these event platforms really work. So on the left, you'll see a user service. On the right, a notification service. And we'll use Kafka as our example. So user service, a user is created. That gets published to a topic. Notification service sends an email that says, hey, thank you for joining our service. Next, a user deletes their account, goes to a different topic, user deleted topic. And the notification service says, hey, thank you for using our service. Please come use this again if you're interested. And then importantly, like one of the reasons why this is a good idea to do for our software engineering partners, if one of these services goes down, like let's say this notification service goes down, more users will still get created by the user service. And effectively, they will queue up within Kafka until the notification service comes back online and starts consuming these messages, these events. So it provides this nice trade-off where your system's more available, and in order for a user to be created, you don't have to also have the notification service up. You can just like if the user service is up, you're good, and we know those emails will be sent out eventually. So let's jump into like a quick example. Avro schema is actually just like a JSON blob. It's here on the left. It's a little bit confusing, but you'll see there are a couple of fields, an ID that's an integer, an email that's a string, and then we have an enum here about if they're invited or active. And then on the right, we see an example event for this particular schema. So we have that ID, email, and state. So why might events be good contracts? So schemas, at least in Kafka, are stored in a schema registry, meaning that there's like a centralized place where all these things exist. In Kafka, at least, events don't necessarily have to match the particular schema, but should they ever not, in our systems at least, this would be a very high priority bug. These messages get routed to a separate queue that effectively wakes up an engineer somewhere, and they go in and figure out what's going on and resend all of those messages, meaning that that makes sure that downstream state for the particular microservice is all accurate. And means for us on the data side that the data in our pipelines, maybe it's a little bit delayed, but it will also eventually be accurate. And particularly accurate within the particular schema. And then also the schema registry within Kafka at least ensures compatibility between schema versions. So if you want to, for example, change the data type, something that could have a really negative downstream effect on our pipelines, because it could lead to new events not being consumed or the table being incorrect or something like that, we actually, those can be effectively restricted by the system. And then finally, and really the most important point that I want to hammer home, events are already contracts. So what this means is an event is something that we expect other teams to consume. So if you're an engineering team building a microservice, whenever you want to change an event schema, you have to go to whatever other engineering teams are already consuming this particular event, make sure it's not going to break anything for them, and coordinate with them rolling out any necessary changes. What this means for us on the data side is that instead of starting a new process and working with engineering to say, hey, please, comply with this particular contract, you just are another participant at an already existing meeting, which means that, you're borrowing existing process instead of having to start new ones. So let's talk about what it would look like to have some of these events get put into a data warehouse like Snowflake. So a user is created, put into Kafka, and it ends up in a user-created table in Snowflake. This ends up being a single row, and it's effectively like you can think of it as a JSON blob, a variant type within Snowflake in that row. So we have a user deleted. That becomes another table here within Snowflake. We see a second user created. This becomes a second row in that user created table. So we can accumulate all of these events about users, and we end up with these three different tables. There's a user created topic, a user deleted topic, and a user updated topic. But we as analysts, as people poking around in data, we want to ask questions like, how many users are active? And that's kind of hard to do with these three tables. You know that there's a bunch of user updated messages, some of them correspond to different users. What's the latest state of the users table is the ultimate question. And that's what, for us on our data engineering team, we want to make it really easy for our BI partners to be able to query this data. And we want something that looks like this. We want to take these three tables and convert them into a users table. So this is effectively what we built, is something to take these multiple topics, figure out what the most up-to-date state is, apply deletes, whatever that means for your particular system, and create this users table. And particularly, we want to make it so that instead of creating one pipeline for users and one pipeline for organizations, one pipeline for products, all of the different important things to your business, we want to instead have there be just a single pipeline, a single DBT macro that does all this. So that's what the rest of the talk is about. So first talking about the contract. We call this the Obvious Model Generation Contract, OMG for short. And the idea is that if you comply with this contract, it's pretty obvious how the domain model is built. And there's a little bit of naming conflict here in what a model is. What I mean by domain model is some business entity in our system. So a user, an organization, or users, organizations, products, whatever it is. Domain model objects will refer to one such entity. So one particular user, like Jill, or one particular product, like Teddy Bear. So what are some important questions that we want this contract to help guide us with? First off, we want to know which topics, so which of the tables refer to a particular domain model. Second, we want to be able to uniquely identify a particular domain model object within that domain model. Third, we want to know what type of state change this is, insert, update, or delete. And then finally, and probably most importantly, what is the state of the domain model object after this change? So with these questions as guides, we created a contract that involved 5 particular points, and we went to the architecture committee for our engineering team and said, got it passed through saying, hey, we are going to, if you want dashboards to be built off this particular domain model, you need to give us this information and in your Kafka messages. So what are the 5 things? First off, we must have the topic name for this particular domain model object, all of the topics, added to a specified DBT variable. Actually, what it is there's a users variable that has a list associated with it that is the list of topics. So new topic comes along that refers to updates in the domain model. You would add it to this DBT variable. Second, we need some uniquely identifying field named ID. Actually, in our system, there's a way to override the name ID, so you can call it something else if you really want to. But the default's ID. Third, there must be a change type field with value insert, update, or delete. Fourth, if it's an insert or an update, there must be a data field that encodes the next state, the next complete state of the domain model object. And then finally, if it's a delete, we must have a deleted ID to identify which domain model object in the domain model is deleted. So let's look at an example of this, because this is just like a bunch of text. So we look at our same event, our same schema again. We have our event, our original event with ID, email, and state. What this looks like after, on the left, it's cut off a little bit at the top, but that should be fine. It actually doesn't look like very much, not a lot changes. Particularly, all of the data that existed in the prior event gets pushed into a field called data, which is a map within the serialization language. And then also there is a change type added insert. So we have events that look like, if I can go back to this, how do we actually translate a whole bunch of events, inserts, updates, deletes, into that actual table that we're interested in? So I won't actually go through the code here because code is scary on screen. There is a blog post that I already posted in the DBT Slack. It will be posted on the DBT blog as well shortly. And it actually has like code snippets and stuff. And definitely if anyone is like, hey, we could also use this, we're thinking about open sourcing it. So let us know. That's something that we're happy to do. So once again, the goal of this, one generic pipeline for all domain models instead of custom ones for each particular domain model. And then leveraging DBT macros. We really like DBT macros at Merit. Lots of flexibility and reusability. If you haven't played with them very much, I suggest it. So our DBT macro architecture. We really have two things that we're hoping to do, which is determine the output column set. So in particular, for this example event, there should be an output column ID, email, and state. So we need to determine that. And then we need to determine the up-to-date set of rows. So what's the current state for each domain model object? So we did this with three particular macros. The first one determines each distinct key in the data field from the state change table. So basically, like currently it goes through all of the domain model, all of the domain model objects, and it goes through all of them and just accumulates this distinct set of what the columns should be. The second one retrieves the most recent update or insert for each domain model object. It also applies deletes by either, depending on your particular use case, it would maybe have a deleted column that's a Boolean true false, or you can actually delete the record and have it not appear in the output table. Of course, you still have all the base data, so you could look at past state if you want to. It depends on how you want to handle deletes. And then the third macro coordinates the activity of the first two. So I'm not sure, how many people here have heard of or used something like run query before? Yeah, it's pretty slick. It's how you'll hear like introspective queries. So effectively you run a first SQL statement, then use the result of that first SQL statement to build the SQL for your next SQL statement. And you can do this all in a single DBT model, which means that we can have this all be a single model that first figures out what the columns should be in the first query, and then uses the results of that to execute the second query. And then it combines those results with the second macro in order to yield the output table. So this is pretty much what we do. Yeah, and we're enjoying it so far. So what does it actually look like to use this macro? The SQL, I didn't even add a little file snippet. It's just one line. So you call the stream model macro within your favorite, Jinja curly braces. And then you pass in what var users refers to as that list of topics that I mentioned that are relevant to the user's domain model. And then also, at this point, we also create a YAML file, which I'm sure all of you are familiar with, for testing and documentation. This is actually the first point in this entire process that we say what columns are supposed to be in this table. And we do this so that we, it's documentation and testing, of course. Yeah. And one of the things I'll talk about on the next slide is that second point there, alerting on event schema changes. So we're also interested in, as event schemas change, hopefully our upstream engineering partners are always telling us when event schema changes, but say there's some bug that gets into the code and we start seeing different stuff. We want to be able to be alerted on this. This is something that we haven't built yet, but we're interested in doing so. A couple of other future ideas. Materialization strategy is absolutely critical. Incremental is definitely your friend. You're getting new events coming in. The old events should be will be effectively static. We definitely want to leverage an incremental materialization strategy. We also have been building out a small little framework to do load testing, particularly for DBT and snowflakes, that we can model like what happens when we have 100 million events in this particular, on this particular topic. What will happen? Are things still good? If anyone is interested, it's kind of like a generic little load testing framework. If anyone is using a load testing framework that they like for DBT specifically, would love to chat about it, would love to talk about what we're building. And then finally, I'm not sure if people have built in-depth, or how many of you have built in-depth DBT macros, but testing them to make sure they work is a little bit tricky. It's easy to use it a couple of times and be like, well, it works in all the cases I've used it in so far. But actually testing it to test all the different permutations is hard. We actually ended up building a really lightweight macro testing framework that does things like mocking out run query, so it doesn't actually hit your database, but all is able to compile locally. So if anyone is interested in that, another thing we're thinking about open sourcing, so come talk to me about it or message me on the DBT Slack about it. Awesome. And that's all I was hoping to talk about today. Thank you so much for your time, and I hope you have a great rest of your conference.
Awesome. Thank you so much, Charlie. I'm glad you were all here for that. Charlie will be answering questions in Slack. You've got a lot of the Slack is picking up, so you'll be busy for a bit. I don't know if you mentioned it in your talk, but if you stick around, the next session is actually, we'll pair chef's kiss with this one. So it'll be Jake from, he's at Okta now. Jake will be coming in to talk about how to use contracts for building data systems with JSON schemas. And he'll be joined by Emily from Drizzly. If you enjoyed this talk, I definitely recommend pairing it with this next one. Thanks, everyone.